In this video, we're going to be looking at how the graph of a function relates to the formula or the actual numbers that define the function. And we're going to be graphing some nonlinear functions. Some functions where the graph is not just a straight line, it has some other shape. So first, remember this example from the last section when we were doing linear functions? This is a linear function. The graph is a straight line with a slope of -1/2 and a y-intercept of 3. And every point on this graph has an x-coordinate and a y-coordinate. And the y-coordinate is going to be f of the x-coordinate. So for example, f of 0 is 3. So there's a point on the graph where x is 0 and y is f of 0, which is 3. F of 4, if I plug 4 in for x and do the calculations, -1/2 times 4 would be -2, plus 3 would be 1. F of 4 is 1, so there's a point on the graph where x is 4 and y is f of 4, which is 1. F of -2, well, -1/2 times -2 would be +1, plus 3 would be 4. Since f of -2 is 4, there's a point on the graph where, oops, I got that mislabeled. X is -2 and y is f of 2, which is 4. And we can go the other direction. I can say, what is f of, well, what is f of 1? Well, I can look on the graph, the point where x is 1, the y-coordinate is, looks like 2.5, halfway between 2 and 3. So f of 1, just from the graph, I can tell that ought to be 2.5, 2.5. Another example we were looking at was where f of x was x minus 4, a line with a slope of 1 and a y-intercept at -4. So all the points on this line have their y-coordinate equal to f of their x-coordinate. So you can see on the graph that f of 6 is 2, because here's the point where x is 6 and y is 2. You can see that f of 3 is -1, because here's the point where x is 3 and y is -1. And in fact, no matter where we are on this graph, at any point on this line, you've got your x-coordinate, and then you've got your y-coordinate, which is f of the x-coordinate. So like here's 6, and then f of 6, which is 2. Here's 1.2, and f of 1.2, which is -2.8. Here's where x is 5.5, and y is f of 5.5, which is 1.5. So all along this line, every point on the line, you've got your x-coordinate, and then the y-coordinate is f of that x. So on this one, I'm giving you a graph, but I'm not giving you a formula. Just by looking at the graph, if this is the graph of a function f of x, you should be able to find f of 4. How do you find that? Well, you look for a point on the graph where x is 4, and then the y-coordinate of that point would be f of 4. Do you see what point that would be? Right here. The point on the graph where x is 4 has a y-coordinate of 1. So we can see f of 4 equals 1. What about f of -4? Do you see the point on the graph where x is -4? The y-coordinate there would be 5. So f of -4 is 5. Now this one's kind of the other way around. Find x such that f of x equals 0. So the first two, they gave us the x and we had to find the y. Here we have to find the x and they gave us the y. That's what f of x is, it's y. So look for a point where y equals 0. the y-coordinate would be 0 here. And then the x-coordinate is 6. So that means f of 6 is 0. So the x that we were looking for is 6. Let's try another one. Here we have the graph of a different function, g of x. I even gave you the formula, but you don't need this. You can ignore this and just look at the graph. Find g of 0. So look for the point on the graph where x is 0, and the y-coordinate of that point would be 4. So g of 0 is 4. What about g of negative 2? Can you see on the graph what that would be? G of 2 would be 0. And what about g of 3? Well, that's kind of a trick question. If you look for a point on the graph with an x-coordinate of 3, you're not going to find one. There is no point on the graph where x is 3. So that is just undefined. 3 is not part of the domain of that function. Now, let's graph some nonlinear functions. So, for these functions, the graph is not going to be a straight line. We looked at linear functions in the last section. That was where you have f of x equals mx plus b, an x term with some number times x, plus a constant term with some number by itself. If a function is like that, it's a linear function, and the graph is a straight line. If a function is not like that, if it has something else going on with it, then it's not a straight line. It's some other shape. So the next 3 examples that we're going to work through are all going to be non-linear functions. So don't expect the points to line up in a straight line. So here we're trying to find the graph of the function f of x equals x squared minus 4 by finding and plotting ordered pair solutions. So what we're doing is we're picking a number for x, putting it into the formula to see what f of x would be to go along with it, and that would be the y that goes with that x. So that gives us an x and a y pair that we can plot a point for on the graph. Like if we start with 1 for x, when x is 1, y would be f of 1. It would be 1 squared minus 4, which is negative 3. So that would give us a point on the graph where x is 1 and y is negative 3. Let's try another x. How about 2? If we put 2 in for x, y would be 2 squared minus 4. So that would be 4 minus 4, which would be 0. So that would give us a point at 2, 0. Point where the x-coordinate is 2 and the y-coordinate is 0. How about when x is 3? Then y would be 3 squared minus 4, so 9 minus 4, and that's 5. So that gives us a point at 3, 5. How about if x is 4? Then y is 4 squared minus 4, 16 minus 4 is 12, and that gives us a point, well, it would be way up here somewhere. It's off the part of the graph that we can see here. So you know what? Let's not go any bigger, but we don't have the full picture yet. Let's look at some x's that are smaller than the ones we have here, like 0 or negative something. So what happens when x is 0? The y that goes with that would be 0 squared minus 4, which would be negative 4. So that gives us a point on the graph at 0, negative 4. How about when x is negative 1? Negative 1 squared. That would be negative 1 times negative 1, so that comes out positive 1. Minus 4 gives you negative 3. So we have a point on the graph where x is negative 1 and y is negative 3. If x is negative 2, y would have to be negative 2 squared, which would be positive 4, minus 4, which would be 0. If x is negative 3, y would be negative 3 squared minus 4, which comes out to be 5. So there's the point at negative 3, 5. And now we've got enough points that I have a pretty good idea what shape they fall into. So once you've plotted enough points that you can see the pattern, the next thing to do is to draw a path, a curve that passes through all of those points. So if I do that, I draw something that goes through all of these points, like connect the dots. That's what it looks like. So that would be the graph of that function. That's the graph of the function f of x equals x squared minus 4. And hint, anytime you're graphing a function that involves x squared, the shape is usually going to be something like this, which is called a parabola. It might be sort of upside down from this. It might be the kind of parabola that opens downward instead of upward. It might be shifted over somehow, up or down or right or left. Might be flattened out a bit or stretched or something, but it would have this basic shape. So one hint that can help you when you're graphing a function is if you have an idea ahead of time what shape the graph is going to take. Is it going to be a straight line? Is it going to be a parabola? Is it going to be something else? If you know what to expect, then it's easier to draw the graph, to get the points in the right pattern and then draw the graph that goes through those points. Okay, we're going to look at a couple more examples, but I'm going to end this video here and save those last two examples for the next video, okay? See you then.